All throughout our discussion regarding crystal field theory or crystal field splitting, we were always referring about weak field ligands, strong field ligands and so on. So, we have to understand in a detailed way what is a weak field ligand or a strong field ligand. How can you understand them, identify which is a weak field ligand or which is a strong field ligand, and what is its place in explaining crystal field theory or crystal field splitting. In order to understand that, we have to switch on to a topic, spectrochemical series. And it is a frequently asked question. You can see the question here. What is spectrochemical series? Explain the difference between a weak and a strong field ligand. What is the difference between a strong field ligand and a weak field ligand? It is an FAQ. Let's see how can we answer this question and try to understand how to identify a weak field ligand or a strong field ligand. So what is a spectrochemical series? Spectrochemical series is the series in which common ligands are arranged in ascending order of crystal field splitting. That means the ability of the ligand to cause crystal field splitting. Those ligands are arranged in the ascending order of their ability to make crystal field splitting. That is known as spectrochemical series. And this is the definition you have to write. Spectrochemical series is the series in which common ligands are arranged in ascending order of crystal field splitting. You can see here, according to spectrochemical series, here we have the strong field ligands at the end of the series and weak field ligands at the beginning of the series. So it starts from here, the strong field ligands CO, Cn minus, NO2 minus, En, NH3, EDTA, NCS minus, H2O, COO twice minus, C2H5OH, OH minus, F minus, S2 minus, Cl minus, SCl minus, Br minus and I minus. So by looking this series, you have to learn this series, and then by seeing or thinking about this series, you can identify which is the strong field ligand and which is the weak field ligand. What is the difference between them? These strong field ligands are able to make large crystal field splitting. Okay, strong field ligands are able to cause large crystal field splitting, and then they are able to make those electrons paired up and cause low spin complexes. Let's move on with another important aspect of crystal field theory, that is relationship between delta knot and P. This is also an important part and it is an FAQ. Let's see the question. How the actual configuration of the split d orbitals in an octahedral field is decided by the relative values of delta knot and P. What is the meaning of the question? See, in an octahedral field, crystal field splitting has taken place. So you know that those degenerated d orbitals have split up into Eg orbitals and T2g orbitals. And after the splitting, how can you know that where those electrons are situated, whether it is in the T2g orbital or Eg orbital? By using delta knot and P values, how can you predict it? That is the question. So what will be the answer? Delta knot is crystal field splitting energy. You know that. That is delta knot. And P is pairing energy. Energy needed for the electrons to get paired up. So, if crystal field splitting energy is greater than pairing energy, the electrons will be able to get paired up. That means you can find those electrons in T2g orbitals. If crystal field splitting energy is lower than pairing energy, those electrons will not be able to get paired up, and so they will get into the higher orbital like Eg orbital. That will be situated in, those electrons will be situated in Eg orbital. So what will be your answer? You will write delta knot is crystal field splitting energy. You know that. And then P is pairing energy. If crystal field splitting energy delta knot is greater than pairing energy P, then it will be more favorable energetically for electrons to get paired and occupy lower T2g level rather than to occupy higher Eg level. That's correct. And then you can just give a shorter notation regarding that. Delta naught is greater than P, pairing is done. That means it should be in T2G orbital. Delta naught is less than P, what happens? Pairing will not take place and those electrons will be found where? In Eg level, the higher Eg level. So that should be your answer. If you write this, you will get full mark. And I hope you have understood the concept behind it. So if you know the delta naught value and the P value, you can just say where the electrons will be situated in which Eg orbital or T2G orbital after crystal field split. We shall wind up the session now. Let's see again.